Guys, welcome back. It's exercise 5.3. We are dealing with Laplace transform. I've taken a liberty of picking one of the questions there, which is number 1E of the exercise. I will explain it, how you do this. It's not really difficult. They're saying in each of the following cases, determine from first principle the integral of infinity and 0 of e raised to a minus st, the function of t dt. So as you can see, we are given a function of t, which is number 1e. T function of t is equals to a 10. And then you replace this function of t with the 10. And then 10 is a constant term, it goes out. And then when you integrate, oh man, it's not this. Guys, welcome back. We are now at exercise 5.3. I've skipped 5.2 for a reason. It's the same as 5.1. It's just that number 3, number 9, number 10, they want you to derive the formulas of your substitution, whether it's tan or sine substitution. So you don't have to do that at this level. Yours is to apply the relevant formulas. But the other exercises are exactly the same as 5.1. So now we're moving to Laplace transform, which is just an introductory part of it. So if we look at 5.3, number 1, they say in each of the following cases, determine the integral from infinity to 0 of e raised to minus st function of t dt from first principle. So I've decided to do number 1e. Number 1e, we are given a function of t as equals to 10. I could have taken any of those ones from a all the way up to t, but I've decided to take this one. The method that I'll use to do this e is exactly the same method that you have to apply to do the remaining ones, especially in that exercise 5.3, that number 1. So you have to replace this function of t with the 10 because you are given a 10. And you realize that this 10 is a constant term. It goes outside the integral sign, and then you are left with an integral of between infinity and 0 of e raised to minus st dt. To integrate, it's an exponential function. It comes back as it is. You divide with the derivative of your power, which is your minus s. And then you have to evaluate between 0 and infinity. And when we evaluate this, as you already know, before you do it, I normally prefer to make the power of my exponent a positive. So I put it underneath the line. You can leave it up if you want, but it makes it easy so that when you evaluate, you are able to understand what you are supposed to get out of this evaluation once you start putting your maximum limit. So if we substitute this infinity, any number that divides infinity, we know it's a 0. That's why I have a 0 there. Then it's a minus, and then I substitute a 0 there. Any number to the power 0 is a 1, which means I'm left with s. But this minus multiplied by that minus, it gives me a plus. If you add the 2, you're left with 1 over s. If you multiply with the 10, you get a 10 over s. So this is how you go around evaluating this exercise 5.3 number 1. All of it. You do get this sometimes in the test or exam for around 5 marks. So what is important here is the steps, all the steps. The answer is not so much important because if you could have said, for argument's sake, chosen a D to say your function of x is a A, here we'll end up with A over S. Or maybe for B, for argument's sake, and say function of t is your minus 2. Here you'll end up with a minus 2 over 10. But we are not looking at the answer. We are looking at the steps that we have here. Whether you write the correct answer and the steps are wrong, and you think you will expect to get a mark for the answer, you get nothing for that. Because what determines the mark over here for this answer is the correct steps over here. So this is how number 1 is done. Let's look at number 2. Number 2, let me just quickly get it. Number 2, they're saying prove that's the integral between 0 and infinity of e raised to a minus sx, multiply with your x, dx is equals to 1 over s to the power 2. As you know that when you integrate an exponential function with another function next to it, you get the derivative of the power of this exponential function. You compare it with this, as in this case, the derivative of this is minus s. Here we've got an x. And you cannot say, I'll modify this and put the x outside and then put a minus. No, you don't touch a function of x because x is a function of x. When you modify, you just add constant terms. So which means we're only left with integration by parts. Integration by parts, the formula is the function of x, gx, minus the integral of the derivative of the function gx dx. Our function of x from the priority table, we know our function of x is x. The derivative of it is a 1. Our e raised to sx is our g prime. And the integral of this to get it to gx is e raised to a minus sx divided by minus s. So we substitute. There I have my function of function of x. There is my gx over there minus the derivative of the function is a 1. There I have it there, and my gx again. There I have it there. So I then remove a minus as well as 1 over s outside the integral sign. There it is there. This changes to a plus. There is my 1 over s. On this side, I make this positive power. It goes underneath. There it is. This negative. It also remains there. You can evaluate this part. There's nothing wrong with that, between infinity and 0 plus 1 over s, and then you integrate this. Remember, we removed this minus 1 over s, became the positive 1 over s. That's why we have this there. So when you integrate this, again, you divide by the derivative of this power, which is a minus s. There we have it there. Evaluate it between infinity and 0. On this side, you will get a 0. Why do we get a 0? If you put infinity underneath over here, because it's an x, so it's an x, you put infinity. Any number divide infinity, you give you 0. But I've gotten questions, I sometimes get questions that says, but also here you must put infinity, and this is also infinity. Why do we get 0? There's a difference between this infinity, in a sense that the infinity that we get in the denominator is multiplied by something else. And also e has a value. If you raise it to infinity, after substituting, if we are given a particular value of s, this becomes greater than the numerator, which means our denominator will be far much greater than the numerator. That is why we end up with 0. Plus, and then we come to this side. If you take this e raised to sx and you make it a positive, there it goes. This 1 over s, we have it outside, and then we evaluate. Let's see what I have. Let's evaluate. Here is 1 over s. There it is. Substitute the maximum limit, which is infinity, minus the minus. We substitute the minimum value of the limit, which is 0. This side, you still get 0 because this number divide infinity is a 0. On this side, any number raised to a 0 is a 1. So which means we're left with a negative, multiply with a positive, which is a plus, as well as 1 over s. Add it to 0, you still get 1 over s. Multiply the 2, 1 over s squared. The steps are important. They lead you to an answer. The answer doesn't carry so much weight if it doesn't come with the correct steps. So make sure that you follow all the steps. It's worth about 5 marks in the exam. And then you do it right. Number 3, where they say determine the inverse Laplace. The plus of that is not part of the syllabus, so we'll leave that one out. So I'll give you exercises to do on this 5.3. You can do 5.3 number 1b as well as number 2b. 5.3 number 1b as well as number 2b. I want to see all the steps that are correct. I'll send you the corrections of these two. And then the next work that we'll be focusing on is the area as well as the volume. I will send you the next video that deals with that. Thank you, guys.